Okay, so now I'll be talking about constructors. A constructor is a special type of method of a particular class. It runs every time an object is created. Here I created an object called C1, which is a part of the class car. So suppose I have a constructor method over here, and the code inside that method will always run as soon as an object is created. This can be used for a variety of reasons. Suppose you want to keep the track of number of objects of a particular class. So then whenever you can have a constructor, and then whenever an object is created, you can increment the value of a particular variable, and that will keep the count of the number of objects of a particular class. And another, the most mainly used reason for a constructor is to initialize data. Suppose I have wheels, these are all my attributes. Just change it to public over here. Okay. So these are I have four attributes, and I don't want to keep doing this. C1 dot wheels equal to 10, C1 dot color equal to red, C1 dot speed equal to blah blah blah. I don't want to keep doing this. I just want to I want to type a certain value, like I want speed to be 10, I want color to be red, I want speed I want wheels to be 10, I want color to be red, I want speed to be 50.6, and I want mileage to be 4,000. I don't want to keep doing C1 dot wheels equal to 10. So a constructor is helpful in these type of scenarios. But keep in mind, it's a special method which runs whenever an object is created. So the syntax for a constructor it goes like this. There's no return type, and it's just the name of the class with parameters. Suppose with the parameters which you want to input. Suppose I have wheels, so my thing is int underscore wheels and string underscore color and float underscore speed and float mileage. And now we take these inputs. Now we assign these inputs to our attributes. Now int wheels will be equal to wheels. So our wheels equal to underscore wheels. Now this wheel is an attribute. It's basically like a global variable for this particular class, whereas this underscore wheels is a local variable of the constructor. So after the constructor execution finishes, this underscore wheels variable will be cleared from memory, but then this wheels will still remain because it's a part of the class and it's an attribute. This is the same. Equal to color. Okay, done. So this is a constructor. The syntax is the name of your class, specify by the parameters you want as input, and then the normal curly braces and whatever you want. And now I don't need to do all of this. Let me just remove this. Now let's create a car. So how do we create a object of a class? We type the class name space the name of the object. Suppose I want my object to be C1, and now since I specified a constructor, this is how you use the constructor. Parenthesis, and first it's wheels. So how many wheels you want? I want 10 wheels of my car. I want my car to be red in color. Speed 50.6, and also mileage. Let's give it 400. And now this is done. Now what this will actually do? As soon as we run this line gets executed, and then since we specified it with parameters, this knows that it's going to pass it to the constructor. So all of these values are going to get passed to the constructor. So 10 for wheels, red for color, 50.6 for speed, and 400 for mileage. And then what will it do? It will assign these values. So this 10 over here is underscore wheels. So it's assigning our wheels, which is an attribute, to underscore wheels, which is 10. So our wheels is 10, and our color, which what is our underscore color? Here, red. Red is passed as the second parameter, color. And our, sorry, this should be, yeah, I made a mistake. Yeah, now our color attribute, which is a part of this class, is set to underscore color, which is from the constructor. And now let's define a get method, which will define another method for a class, not a constructor. Void display. Let's call it display. Let's print out all the values. Let's do wheels. I'm spelling correct. And let's do handle color wheel value. Okay, now we call display c1 dot. We do a dot operator because it's a method for a class. We access methods and attributes of a particular object with using the dot operator. So we do c1 dot display. Let me save, and then we compile. I hope you guys know how to compile. Main.cpp main. Now we run it dot slash main. See, we get 10 red and 50.64 whatever 50.6. Oh, sorry, forgot. Over here, that's why it's printing out 60.4, 50.6, and then 400 over here. But to add a new line, so just save it, compile it, run it again. It's 10, the wheels 10, the color red, the speed 50.6, and 400. Suppose I want to print I want to print hello every time I create an object. So how am I going to do it? I'm going to print it out in the constructor, because a constructor always executes whenever the object is created. It's by default it executes. You don't even need to call it. And I do cout hello our object created. Then I save it and compile it. See, every time my object, and I create another car C2 40, suppose it's blue, suppose it's 40.3, and suppose it's 60.1, and I save it. I'm not calling c2 dot display for this car, but by default our output we should have this printed out for c2 as well, because we're passing it with a constructor call. Now compile it, run it. See, we get it 2 times. The first one is for c1, the second one is for c2, and then c2 dot display is getting called. Yeah, and destructors are the same thing. So what do destructors do? Destructor, it's also a special method, but then it's called when an object is destroyed and it's getting removed from memory. See, a constructor is called when an object is created. So when memory is given to a particular object, we're assigning certain memory for C1 object and C2 object. And when we are doing that, we're calling the constructor. Destructor is called when we are removing it. Suppose it gets deleted. When does it get deleted? When do objects get deleted? When the main function finishes execution and the program ends. That's when all the memory is freed. Suppose I created this. I create a destructor. This is the syntax for a destructor, by the way. Use the tilde, this squiggly line. You can call it whatever you want. Same as the say it's just the same as the constructor call. Class name. You don't need any parentheses because you're destroying. You don't pass it any parameter when you destroy it. Automatically gets destroyed. And when the object gets destroyed, what do we want? Let's just say object is destroyed on memory speed and then we save it, and then we compile it, then we run it. See, first C1 is created. C1 gets created, and then C2 gets created, and then the constructor executes these two, and then I call my C1.display function, and then it prints out all the way here, and then our our main function ends. After this, there's nothing. Our main function finishes execution. So then it deletes everything from the memory, including C1 and C2. So it destroys C1, all the memory is freed, and then destroys C2, all the memory is freed. So this is how destructor works. And this is something called parameterized constructors as well. You can overload constructors as well. This is a parameterized constructor, by the way, putting parameters, and you want a default parameter, the default constructor. So this is how you do a default constructor. You can this. I hope you know function overloading. You have studied it before, but you can overload constructors as well. Suppose I only have the information for wheels, string, and wheels, color, and speed. I don't have the information for mileage. So we can assign. We can do it like this. We can take int wheels, color, load underscore speed. Okay, that's it. We only have three values. We have speed, we have color, and then we have wheels. We don't have mileage. So this is one. This is another constructor. This is a constructor. This is a constructor as well. The constructor, the specific constructor gets executed based on the number of parameters. Suppose again, wait. I'll write this and explain it. Wheels equal to underscore wheels. Color equal to underscore color. Speed equal to underscore speed. Okay, we don't have anything for mileage. We can just leave it as, we can just leave it like this, and then only wheels, color, and speed get assigned, and mileage gets assigned a garbage value. But then if you want to be safe, we can always assign mileage to some obvious value like -99. This will tell us that this mileage is not, we don't have any particular value for this. And now we can call, suppose I'll delete car C2. Car C2. I want to call it using this constructor, the second one, which has only wheels, color, and speed. And I'll specify wheels as 4 wheels, color is blue, and what is our speed? Our speed is 40.9. Nice. Instead of C1.display, I'll do C2.display. Save it. And then compile it, run it. See, first C1 gets executed. The C1 gets executed, the constructor of C1. We passed 4 arguments for it, so it's going to construct using this constructor since we passed 4 arguments. And then C2 does not execute hello car object created, because C2 is created using 3 parameters, and a 3 parameter constructor does not have a C out hello. It does not have this. As you can see, there's no hello object created from this in the three parameter constructor. So that won't be executed. And then I'm calling C2 dot display. I'm calling the display function of the C2 object, and it's going to display its wheels, which is 4, correct, the color, which is blue, and the speed 40.9. And since we didn't assign anything for mileage, I mean we did assign it, but we assigned it to some uh, random value, which is minus 99. Suppose we take it off because we don't have mileage, then we save it and we compile it, and / min. See, we're gonna get some garbage value. So this is what these are what constructors and destructors are. You can overload constructors like this based on the number of arguments you want, and yeah, that's it. And now, so we created constructors and destructors for a particular class. Now we created the first object C1 using the fourth parameter constructor. So by default, since we pass 4 parameters, it's going to use this constructor method to call create the object. And then the second object is created using the second constructor which takes 3 things. So this is going to be executed. This won't be executed, by the way, only this one. And now suppose we try to create another object car C3 which has without using constructor car C3, and then I save it, and then I create it, and I try to compile it. I'm going to get an error because as soon as we created a constructor, we need to create a default constructor which will which will get executed whenever we create an object without passing any parameters. Suppose C3 is created without passing any parameters, and then but then we still have constructors with 4 parameters and 3 parameters. This will throw us an error. So we should handle the scenario where there is 0 arguments. So for this, I create a constructor which takes 0 arguments, and then I just leave it like this. Or suppose you want to be more safe, I initialize the race attribute to uh, minus 99, color equal to minus 9, color equal to null, and then speed equal to minus 99, and then mileage equal to minus 99 as well. And I save it, and then I call c3.display, save it, and then now I can compile it. It's going to go /1. See, I got minus 99, null, and minus 99. Suppose I just remove all of this. Remove all of this. It's gonna get garbage values. Save. Here. Compile. Done. See, I'm just gonna get the garbage values. When we more safe, just initialize them to some random value, like which will be obvious that we don't have any value for that particular field.